In this video, we will do one more example of the quadratic formula. The equation we'll be playing with is x squared plus 3x minus 4 equals to 0. You'll notice in this particular case that this thing can actually factor, which means that we don't need to use the quadratic formula at all. However, the quadratic formula I want to be very specific about is a catch-all. You may use, again, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, assuming it's of the form ax squared plus bx plus c equals to 0, for any quadratic. Again, as long as it's in this form, you may use this formula. So over here, this one here will factor, and it will factor into the two solutions that I'm going to write up here as x equals negative 1 and x equals 4. Again, if you don't believe that, go ahead and do the factoring and verify that. We're going to go ahead and show you how this will simplify down to those two solutions. So, one more time, identifying your a, b's, and c's. In this case, there's nothing in front of x squared, so I'm going to put a 1 there. That there is my a. The 3 alone is my b, and the negative 4 is my c. Be very, very careful to make sure that the signs get plugged in with the constant it's replacing. So, my formula is x is equal to a negative my b value, in parentheses is 3, plus or minus the square root of my b squared is 3 squared, minus a 4. Again, this 4 is from the formula. This 4 is from the formula. Then my a value is 1. And my c value is a negative 4. Be very, very careful to make sure, again, all of these numbers you're plugging in end up in parentheses. This is all divided by 2 times my a value being 1. So this sets me up to have, again, a simplification inside the radical, a simplification here if possible, and a simplification down here if possible. Make sure, again, you don't try to simplify everything in the first step. Do it in stages. So I'm going to go ahead and simplify this 3 times a negative and make it negative 3. Plus or minus, I'm going to go ahead and simplify what's inside this radical. This is 9 minus 4 times 1 times negative 4. So that's a negative times a negative, which makes it a positive, and it's 9 plus, again, 4 times 4 is 16. So that ends up being the square root of 25. Again, 9 plus 16 is 25. This is all divided by 2. Now, at this stage, we're going to go ahead and try and simplify this radical. Again, first step is simplify the inside of the radical. The second step is simplifying the radical as a whole. So the square root of 25 we know to be 5. So I'm going to go ahead and rewrite that as just 5. In this step here, you'll notice again that if I can simplify the radical, I must, and if I can eliminate the radical, I must. In some cases, you'll notice that this radical won't disappear, so you'll have something that looks like this as a final solution. However, in this particular case, because the radical disappeared, I can view this as negative 3 plus 5 over 2, or the solution of negative 3 minus 5 divided by 2. And again, these will both be solutions to my quadratic equation. So, this one here you'll notice is negative 5 plus 3, which is going to be your value of 2 divided by 2, which provides you with x equals 1. And again, don't forget that you're solving this equation. This x should technically be written down for all of these cases. There's your first solution. Your second case here is negative 3 minus 5, which is negative 8 divided by 2, which is x equals to a negative 4. And you'll notice again, if you were to factor this from the beginning, it factors into x. You have a plus 4 and an x minus 1, which again, when solved as two separate cases, give you those two values. So again, this is what we got when factoring. We should get the exact same thing we use in the quadratic formula. One more time, this is a catch-all method. This is a catch-all method. You may use this for any equation that looks of this form.